We are live. So today's topic, what we're going to do is we're going to be solving quadratics, okay? So what we're going to do is we're going to be finding the zeros, which are also going to be X-intercepts of quadratics. Quadratics is another fancy word for basically parabolas or for any x squared equation, okay? So we're going to find the zeros, which are also called the x-intercepts, okay, of quadratics. Sure. How's that? You like that better?
No, like the zeros. It's like.
No, zeros is plural.
It's not zero.
Come on, Bryce.
Oh, I get it. You put an apostrophe at zero.
He's too young.
I'll put it.
Yeah, he's
Okay.
too young.
Now, before we do anything, okay, check it out. I'm going to draw a little picture here.
Senior year, I think.
So, Price is going to help answer your question, okay? So, if we were to graph a parabola, and we've been doing that lately, what we find is there are two, right? There are two x-intercepts. It is possible to have none, but what we're going to be doing is looking at ones that actually have two answers, okay? So when it says, and I got in bold, two answers, what we're looking for really is those two values, all right? So we should have two answers always. So anytime you see an x squared, anytime you see an x squared in an equation, you always have two answers. Okay, I'll say it again. Anytime you see an x squared, you will, in an equation, you will always have two answers, okay? Really. And we can prove it because we're going to start off with factoring. So let's find the zeros, and the reason they're called zeros is because what is the height of these values? What's the y value? 0. And that's why they're called zeros. They're also x-intercepts, right? Because if this is the x-axis, that's where it intercepts the x-axis. We're going to someday call them roots, but we won't call them roots until we start to talk about imaginary numbers, which you guys have never done before, right? Imaginary numbers,
Okay, we're not.
Okay, right. That's usually an Algebra 2 thing. We might do a little itty bitty of it in here, okay? Because you guys are very smart and very advanced, okay?
We're not.
Now, so here's how it works. We're going to, and it's that darn F word. It's that darn F word. We're going to factor. We're going to factor. So, example 1. Let's factor first. Okay? Right? Factor first x and x, right? Plus 4 plus 3 equals 0, okay? So I factored it. I kept in mind that there's still an equal 0, okay? Now there are two answers. So whatever answer I get will make the equation 0. What other answers I get will make the equation 0. Well, it's really easy. If you can factor, this is really easy. So what I have is two little equations. I've got a x plus 4 can equal 0, and I have an x plus 3 equals 0. So what I do is I factor it. And after I factor, I make these what I call mini equations. I got my little mini equations, right? So after I factor it, it equals 0. Now the difference is today is the equal 0. So after we factor, we go a step further. Okay, we're going to solve. We need to solve. So the difference today versus all the other days is after we factor it, we need to solve. So we get two little mini equations. Well, these are pretty darn easy to solve, right? Plus, minus 4, minus 4. One answer is negative 4. Minus 3, minus 3. The other answer is negative 3. Okay, now, that's all you have to do. But I want you to watch, okay? Those are the answers. You don't need to do any more, but I want you to watch this. Okay, they're called zeros because if I were to plug them in, okay, I want to show you on my calculator, okay? So if I go, for instance, negative 4 squared plus 7 times negative 4 plus 12, I get an answer of 0. So they're called zeros. They are the values that make the expression 0. And if I tried the negative 3, it also works. You do not have to do this. I merely want to show you why we call them zeros, okay? So I plug in negative 3. You watching? I should get an answer of 0. So these are the two values that when plugged in, these are the values x that will make our equation 0, okay? That's how it works, okay? So let's look at number 2, okay? Same thing, what's the first thing we do? Factor. So we want to factor first, and then many equations to solve. So this factors into what?
X plus 5 and x minus 5.
X plus 5, x minus 5, right? So factor first, and then set up your mini equations, right? Austin, I know you're with me. Of course you are, right? So we factor. Then we set up our mini equations, right?
You said yesterday.
Right?
It's just all opposite.
Yeah, it's just all opposite. It is all opposite because the way how do we solve equations? By doing the opposite. So you're totally right. Isaac's saying, well, then the answer is just -5, and the answer is just +5, right? Because you would, Isaac, you're totally right. You go -5, -5, exactly. +5, +5. Did you hear what Isaac said? Yeah. Yeah. Now we're going to have to be a little careful when we get to 5, though, Isaac. Okay. So those are the zeros. Easy. If you can factor, this is easy. Okay. 3. What do you do about 3? What do we do about 3?
Factor.
Factor x, right? -4 plus 2, right?
How do you know that so easily?
I've been doing this a long time, Ben.
Because that would take me like 3 minutes each.
Well, I've been doing this way too long, I know. I have a sick mind. Ask Landon, he'll agree. I have a very sick mind.
That's
So our answers are x equals 4, because Isaac said the opposite. And the opposite makes sense because you go +4, right? And -2, okay? Thumbs up so far? 1 thumbs up, 2 thumbs up, any sideways? Any sideways downs? Okay, all right. Number 4. Now to do number 4, let's add a little step here, okay? We need to set equal to 0. Okay, so before we even factor, you need to make it equal to 0, okay? So before we even factor, so if I need to make it equal to 0, I'm going to bring over the x. Okay, I need to bring everything to one side, okay? Bring everything over to the x. So I'm going to subtract x, right? So to bring over the x, I'm going to subtract x. I'll have an x squared minus an x. To bring over the 6, how am I going to bring over the -6? Plus the 6 equals 0. Okay, so I subtracted the 6, I bring it over, subtract the 6, subtract the x, add the 6. Okay, now,
x plus 6 equals.
so now, can you factor it?
Yeah. You take an x.
X, okay. What times what makes,
No, 3 and 2.
this one won't factor. Uh-oh. Darn it.
Is it prime?
It is prime, won't factor, so no solution. Kind of glad I did that one on accident. I meant it for the factor, but it doesn't. Darn it.
And we have to watch out for number 5 because there's a
Wait, how do you know when it's prime?
Good call, Ben.
Yeah, good question. Okay, who asked that question?
Me.
Price, what times what makes a +6 that would add to make a -1?
Then why is it a problem?
It won't factor.
Is it like a little, is it like, are they
I should have made that a plus. That's what I meant to make it. But when I typed it up, I forgot.
Oh, you typed it up?
I typed it up, yeah.
Oh, wow.
Yeah.
Good
I-
job. I thought it was
No, it's my problem. No. Okay, number 5. Let's do 5. So, what's the first thing we got to do? First thing. Yes. So, how do I bring over the 11x? What do I do to bring the 11x? Subtract the 11x. So, 2x squared minus 11x. How do I bring over the 5?
plus it.
Plus the 5, right? I mean, we're far enough in algebra that I don't need to show that step. Agreed? Agreed? Bring it over, so I subtract it. Bring it over, so I add it, right? Will it factor? Yes, this one actually does factor. Okay? Right? 2x, x, right? What times what makes 5?
1 and 5.
So let's put the 1 and 5. Remember my double smiley? Is it going to work?
Yeah.
It does work if you check your double smiley, right? If you check your double smiley,
Wait, I have a question.
-10x, just a sec, -10x, -1x will make the -11, right? Okay. Ben, real quick, yes.
Why is it a -1 and a -5 rather than just a +1 and a +5?
We need -11, don't we? If they're both positive, we'd get a +11. Does that make a little sense? Okay. Now, Isaac, you brought up a really good point. Isaac said just take the opposite. But the problem with the 2x minus 1 equals 0 is you got to be a little bit more careful in just taking the opposite, right? So how would you solve for this? Yeah. +1, right? +1, 2x equals 1, right? Divide by 2, x is 1/2. 1/2. Does that make sense? I went +1, divide by 2, and I get 1/2. Or 0.5, right? And of course, on the other one, x minus 5 equals 0. We'll take what Isaac suggested. We'll just take the opposite, right? We'll get x equals 5. Because most of the time, Isaac, that does work, right? Okay. Am I going too fast? Okay. Okay, number 6. Okay, now think back to your warm-up, okay? Think back to your warm-up. Think about the one Nick did. You guys remember that warm-up that Nick did? Okay. This one's called common factoring, isn't it? Right? So if we common factor, they have a common x, right? We have an x minus 6 equals 0, right? And we still have two little mini equations, right? We have an x equals 0, and we have an x minus 6 equals 0. Well, this one's already solved, right? It's already solved. 0 is a number, 0 is a number, 0 is an answer, okay? So one answer is 0, and the other one's going to be x equals 6, right? Right?
It's a shade.
This x here?
How'd you get that?
Okay, great question. Okay, you ready? Gotta listen. So, when you factor, Cody, when you factor this, it's not what we call a trinomial, okay? So we got a common factor. What do the two terms have in common?
Yeah, that's the part I get. I don't understand where x equals 0.
Oh, well then let me back up. So in all of these, we had little mini equations, right? So even in this, we have a mini equation. Our first mini equation is just this, right? Yeah, from here, this mini equation and this mini equation, this one's already solved, isn't it? Right? And 0 makes sense, Cody, because when you think about it, just common sense, right? If x were 0, what would you get? If x were 0, what would you get? 0, right? So x 0 has to be an answer just by thinking about it, okay? Okay, you guys ready to turn the page? Good question, Cody. All right, example 7. Old stuff. Let's see if we can do it, okay? So, line of symmetry. How do we do it?
-b over 2a.
Yes. A is 1, B is -3, and C is -10, right? And I keep going through this one because it's the one we're still not very good at, right? It's a 1x squared. Great question. Okay? So my line of symmetry is going to be a -3 over 2 times 1, which is a 3 over 2. 3 over 2, which is a 1.5. Okay, so on my graph, I'm going to go take a look at 1.5. There's my line of symmetry. Okay with that? Yeah. Yeah, 3 over 2, 1.5, right? Now, the vertex has to lie on that line, right? So the vertex is 1.5 something. So my vertex is 1.5 something. So I plug the something in. I'm going to go y equals 1.5 squared minus 3 times 1.5 minus 10. And I'm going to use my calculator, right? Use the calculator to plug it in. So can you see my calculator? Sure. So I'm going to go, all right, clear. I'm going to go parentheses 1.5. Well, a vertex is a point. And so it has an x value, and it has to have a corresponding y value.
I get that, but like, why are you plugging it into that equation?
Because that's my parabola. That's what I want to graph, right? right? Minus 3 times 1.5, right? Subtract 10, and I get an answer of negative 12.25. Negative 12.25. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.25, about there. And hold on.
Right at the end when I say.
Hello?
Hello.
Hello.
No, this is a classroom. Goodbye.
What was that?
Is this a business? Is this a blah, 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 blah? Like, what the heck? How'd they get in? How'd they get in? Anyway, I got an answer of y equals a negative 12.25. Normally I ignore it, but right now we're trying to get materials from publishers to buy a new book. So anyway. Okay, so there it is, right? Y-intercept. Y-intercept. Come on, you guys. Yes. How is that? Right about there. How's that? Is that better?
Wait, how'd you get?
Okay, Celeste, how'd you get negative 10?
You are so right.
Oh, it's in that equation.
Right, because if x are 0, right? Nice job. So we've got a 0, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, I got another one there. You guys agree? I got a pair. I got one here. I got one there, and I got one there, right? How am I doing? What about now X-intercepts? Guess what?
We're doing it.
We're going to do it. That's what we just, to find the X-intercepts, that's what we just did here, isn't it? Ah! So 0 equals x squared minus 3x minus 10, right? So the X-intercepts are when we're going to find when y is 0. Well, we'll set it equals 0. We'll factor, right? Hey, this is what we just learned, right? X minus 5, x plus 2, right? Ben, I'll slow down. Okay.
Positive 5.
Isaac's totally right.
Wait, no. Wouldn't it be negative 2, positive 5?
We need a negative 3, don't we? When we, but the answers, you ready for the answers? Don't let this freak you out. The answers will be a positive 5 and a negative 2. Because we do our mini equations. Yeah. Isaac, I'm going to show the minis so they get it, right? So we get x minus 5 equals 0, x plus 2 equals 0. We get x equals 5 and x equals negative 2, right? So those are going to be points 5, 0, negative 2, 0. Slide it up. 1, 2, 3, 4, 5. 1, 2, and then we can graph our parabola in. Yeah.
So as long as you can find the vertex, you don't need, because yesterday I got the same thing without doing any
Right.
work.
As long as, Nikolai, yes. As long as there's a 1 right there. Yes. But there's a different number there, no. Okay. All right, now, like this one, right? All right, here we go. So, number 8, here we go. It's a little bit more difficult, but I think we can do it. So, a rock is thrown off a 64-foot cliff, initial velocity of 48 feet per second. So, we're taking a rock, we're standing on a cliff, we're chucking, okay? We're chucking, right?
Parabola.
Oh, that is cool.
Whoa.
A 3D parabola.
That is awesome.
I'm not good at
How
it.
did you do that?
It's actually, are you ready for this, Cody? It's actually a hyperbola. But we'll learn that later, okay?
Cody, you failed.
Cody's water ball?
That's pretty cool. That is a hyperbola, not a parabola, but that's pretty cool.
Hydroperbola.
It's a hydroperbola.
No questions asked.
Okay, now. Okay, check it out. So it goes something like this. You with me? Okay, there's a picture. Okay. Here's our equation. Okay. So in our equation, there's three things you need to see in our equation. Okay. One, this is gravity. This is gravity on Earth in terms of feet per second. This is gravity in terms of feet per second. This is gravity. This is your initial velocity, how hard you throw it. Since it's positive, we threw it up. if this were negative, we would chuck the rock down, right? And that's our starting height, okay? Okay, now these are things you're going to learn more in science, but I'm throwing it at you anyway, okay? So, right off the bat, what is the maximum height and time? That's our vertex, right? So how do we find our vertex?
Because that's not the maximum height.
The negative b over 2a.
Yep. You are. So it's going to go up, hit its maximum height, and come back down, right? So Saul is right. If we want to find the vertex, negative b over 2a, which is going to be, so a is negative 16, b is 48, c is 64. Okay, so I'm going to go and make this a negative 48 over 2 times negative 16, which I think is 1.5. 48 over 32
No.
2 times negative 16?
is 32. Yeah, I think the whole thing is 1.4, 1.5.
Oh, okay.
Yeah, no, negative 48 over negative 32, which I think is 1.5.
You think?
I'm pretty sure. I could use my calculator.
Yeah, because 16 plus 32 is 48.
There you go. Or I can just use my calculator. Sometimes it's fun to just think. 1.5. There you go. Okay, now, so does this answer make any sense?
Yeah, no.
Yes.
The time, 1.5 seconds.
Sure. 1.5 seconds. 1,001. Right? Makes sense, doesn't it? Okay. Actually, for time-wise, it makes total sense. What's the height? What's the height? Plug it in. Plug it in. So we're going to go h of 1.5 equals negative 16 times 1.5 squared plus 48 times 1.5 plus 64. I'm going to plug and chug with my calculator just because, okay?
I can't see the.
There you go. So I'm plug and chug with my calculator. I'm going to go negative 16 times 1.5 squared plus 48 times 1.5 plus 64, and I get 100, okay? So we throw it about 100 feet. Does that answer make sense?
Yeah.
Okay, it does, doesn't it? Okay, you guys can throw a ball or a rock 100 feet in the air, can't you?
Yeah.
I'm sure you can, right?
Notes has taken us over 20 minutes.
That's good. Okay, now finally, when does the ball hit the ground? Here comes what we learned today. So, easy question. Easy question. When it's on the ground, what's the height?
0.
Right? So let's set it equal to 0. Okay. So if we go 0 equals negative 16t squared plus 48t plus 64. Now, okay, so we set it equal to 0. When it hits the ground, the height is 0, right? Now, so I gotta factor that, but maybe there's an easier way to do it. Well, what I recognize is that I could divide by negative 16. Can you see that? Can I divide all of those by negative 16? And if I divide everything by negative 16, I'd have 0, right? Equals a 1t squared minus a 4t minus 4. 64, no, that's a 3. That's a 3 minus a 4. There we go. Okay? There we go. Can you factor that?
Yes, we can.
I like it. And what does it factor into? What does it factor into? What does it factor into?
2.
Nope.
12.
2 minus 4 and 2 plus 1.
T plus. Some T.
T minus 2 plus
Does it have to be a plus to make a negative 4?
minus 4 plus 1.
That's what
Okay. Okay. So now mini equations, right? Mini equations. So Isaac said just do the opposites, right? So we get t equals 4 and t equals negative 1. Okay. Does that make sense? 4 seconds, right? Goes out. 4 seconds, hits ground. But what about the negative 1?
The negative 1.
Well, I mean,
Does it go?
that's where you would have thrown it if you were standing on the ground.
That is this spot right here, which never happened, did it? That's that spot there, which never happens. So you throw it because you can't have negative time. Cannot have negative time. So there's your answer.
That was too